How are Rossby waves predicted? Imagine trying to forecast a giant ripple moving across the sky. That's similar to how scientists predict Rossby waves in the atmosphere, especially over the polar regions. These waves are huge undulations in the jet stream caused by Earth's rotation and the way the Coriolis effect changes with latitude. But predicting them isn't as simple as watching the sky. It involves a mix of observations and computer models. First, scientists look at current weather data from satellites, weather balloons, and ground stations. These sources give real-time information about wind speeds, temperatures, and atmospheric pressure. They pay special attention to the jet streams, which act like highways for Rossby waves. The jet streams are fast-flowing air currents high in the atmosphere that guide the movement of these waves. By tracking how the jet streams shift and change, meteorologists can get clues about where Rossby waves might form and how they will move. Next, they use numerical weather prediction models. These are complex computer programs that simulate how the atmosphere behaves. They take the current weather data and apply physical laws to forecast future conditions. These models include calculations for vorticity, which is the rotation of air parcels, and the way the Coriolis effect influences movement. They also incorporate the beta effect, which is the change in the Coriolis force with latitude. Near the poles, this effect is weaker, so models need to adjust their calculations accordingly. In polar regions, the prediction process gets trickier because the usual mechanisms that generate Rossby waves at lower latitudes are less active. Instead, local factors like sea ice loss can create heat lows that disturb the atmosphere. These disturbances can trigger Rossby waves, but they tend to be weaker and more spread out. To account for this, models include data on sea ice extent and temperature anomalies, which help forecast how these waves might develop. Scientists also analyze the polar vortex, a large circular wind pattern that forms over the poles. The vortex's stability and shape influence how Rossby waves behave. If the vortex is strong and stable, it can suppress wave activity. If it weakens or becomes distorted, waves can grow and impact weather patterns further south. So, models monitor the vortex closely to improve predictions. Overall, predicting Rossby waves in the polar regions involves combining real-time data, understanding local influences like sea ice changes, and running sophisticated computer simulations. These tools help meteorologists forecast how these waves will evolve and how they might influence weather and climate in the polar areas and beyond. It's a careful process that keeps improving as technology advances, giving us better insights into the complex dance of atmospheric waves over the icy poles.